can do it. Pop the chat out. There we go. Oh, come on, silly mouse. Okay, YouTube, please give me the live channel so I can click it myself. Thank you. There we go. At least I have one viewer then. Alright, there we go. Live. Alright, quality is again and not the best. But that is 1080p and YouTube downgrading the shit out of it. Still sad about that part, but hey, at least I got the rest working. Alright. We did a trick, and I'm gonna recount it again, and then we're gonna start cutting and do it that way. Because if we did it correctly, and that's the whole thing we did, is 1, 2, 3, 4, 5, 6. And we have a cut here. And then we get, that's the leftover, so I'm gonna need the small pin for this one. So 1, that's the first one, so that's this one. 1, 2, 3, 4, 5, 6, 7. That is 1, yep. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Grab the pin over. On the next one. So we need to have 16 without getting on the soldering lines, because I assume, or I'm building a project where you don't need a soldering device. So if I end up at those soldering pins like these ones, the connection parts, these ones, don't work. So that's a problem. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And we have one step at the end. And 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This the next one should be hittable. Because then we have one more, and then one more, and then we should add at the soldering. So you have here 1, 2, 3, 4, 5, 6, 7. And then we have 5 more left, but we're ending up, we should be ending up at the soldering point. So 1, 2, 3, 4, 5, 6, 7. See, and then we end up here. So that's the first one where one before, so 1, 2, 3, 4, 5. So the have 16, so number 10 needs to count up 8 and the rest should be fine. So if we go back 1, 2, 3, 4, 5, 6, 7, and if we can go 1 next, it happens up again. If we go 1 before that, then we should be fine. So 1, 2, 3, 4, 5, 6, 7. Right, so then it's... Nope, lost count, damn it. I lost count. See, this is the part where you actually double check, because if I don't double check... Here we go again. But I hope everyone's day is going alright. I'm a little bit busy counting. If this counting works, then we're fine, but that's the hard part. So 1, 2, 3, 4, 5, 6. We're gonna lose these 6 directly. We can disconnect them and use them on the inside of the lamp to use this part at least. At least that's the idea. Hopefully I can connect this one on the PCB and then that works. And this is just a flimsy connection with 6 LED strips, which you can disable at the start, which is pretty easy. But then 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That's 2. 1, 2, 3, 4, 5, 6, 7. That's 3. 1, 2, 3, 4, 5, 6, 7. That is 4. 1, 2, 3, 4, 5, 6, 7. That's 5. 1, 2, 3, 4, 5, 6, 7. 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And now we should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 off. So if we go 1 up here, then the rest should be fine, because we're going 1 off, plus off. And we have that setup of... Ooh, wait, does this work? So we're at 1, 2, 3, 4, 5, 6, 7, 8. Should be fine. So 1 more should be fine. So 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 6 left. So 1, 2, 3, 4, 5, 6, 7. I think if we do the 8 here, we extend it by 4, because then we have 2 cycles going up. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we go 8 here, we extend it by 1 again. Yeah. So 1, 2, 3, 4, 5, 6, 7, 8. But 8 plus 7 is 15. So if we go by 9, so the number 10 we need to go to 9 again, I think, because then we get that. So number 10 is 9, and then 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There we go. And then we go 1, 2, 3, 4, 5, 6, 7. And then we added the soldering strip, which is not bad because 16. So number 10 needs 9 and all the others are 7. And then we disconnect 2 off after 9, make it 7 again, and then it should be fine. I hope I'm not fucking this one up. Ooh. Yeah. Okay. Ooh, that's scary. Ooh, let's grab a drink. the other part working? Cool, alright. So at number 10 we need to skip to 9, and all the others are 7. 6 to 9 and 7s. That should be fine, right? I'm not fucking up, right? Alright, so this one goes back here again. Oh, here's the scary part. Okay, so 6 gave the best resolution for one skip. Because it doesn't matter if we end up, because 7 to 7 is always one short, so every X amount of cycles you always end up at it. So it doesn't matter where you start. That's the sucky part. So I'm keeping the counties. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's the first cut we gotta make. Ooh, yeah. I've double checked it. I've checked it off stream too. I checked the numbers. This should be correct. Otherwise, I need to wait a week because I'm out of lead strips. Well, complete sets. I can prototype on, that's easy, and then solder a little bit and fix it. But the goal of this is that you can build it without soldering. 1, 2, 3, 4, 5, 6, 7. Because if we do that, that means more people can actually build a lamp. 1, 2, 3, 4, 5, 6, 7. And if more people can build a bed, I reach more people, and that's a good thing. Two. At least that's the goal, right? 1, 2, 3, 4, 5, 6, 7. Because it would be a shame, like you only do soldering part, and maybe that's 10% of the people you can reach. If you can reach more people, well, more people excited, hopefully more people buy the product, and that's the goal of selling things and designing things, if that people want it and hopefully want to build with it. But you don't want to force them into secondary products that you need to assemble it or need to build it or need to have it. So I'm trying to reduce that point as much as I can. 1, 2, 3, 4, 5, 6, 7. Because I think in my mind that should be a good product to design. Because if you don't do that, yeah, that's a problem. And then for me it feels like shooting myself in the foot, because I'm not reaching the audience that I could. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I need to be extra careful here, and yeah, people need a cutter, and that's it. As long as you do that good, it should be fine. And even with that, I should be able, if people don't have a cutter or a scissor. Oh, I need to test this with scissor, because I have a good cutter. Can you actually do this with a normal scissor, that you can cut this? I'm gonna test it on the old one, not this one, because I want to get the other prototypes on. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And I had a couple people asking, like, why can you not make the lamp bigger? Well, it's technically 24 centimeters dot 7 height, so 24 comma 7 dot 7, and most printers are 25 centimeters or more. And I want to reach a bigger audience that people can actually print it. So I don't want to say like I'm gonna make it so big that you can only print it on an Excel or other big printers. Like, you're shooting yourself in the foot again. 1, 2, 3, 4, 5, 6, 7. And that's not smart. So we need to design it in a way that actually is compatible with more printers and more people can access it. At least that's the goal. 1, 2, 3, 4, 5, 6, 7. One, 2, 3, 4, 5, 6, 7. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 1, 2, 3, 1, 2, 3. We're going to number 10 right now. So this should be the one where I should go to 9. Because we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7. Guess I'm losing count again. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's one out. 1, 2, 3, 4, 5, 6, 7. We have normal 7 again. That's one out. 1, 2, 3, 4, 5, 6, 7. And that one comes out. 1, 2, 3, 4, 5, 6, 7. That one comes out. 1, 2, 3, 4, 5, 6, 7. That one. 1, 2, 3, 4, 5, 6, 7. That one. 1, 2, 3, 4, 5, 6, 7. Yes. Okay, cool. I did it correct. As I said, at number 10, we're going up to 9. This is number 10, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. That one goes over. 1, 2, 3, 4, 5, 6, 7. One, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. One, 2, 3, 4, 5, 6, 7. One, 2, 3, 4, 5, 6, 7. One, 2, 3, 4, 5, 6, 7. And that's actually the last one. Yeah. Okay, I need to write that down, because if I do one more in the step, you cut them both off, and you can do that because you have a couple spares. So if you skip one here and start from this one, so you have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and then we always skip, and then we have a couple over. So this is the leftover, and that's the starter. So this is all you have left over. And I think this is this actually 1 meter? Huh, I'm curious. Let's see. Okay, so technically you can do it with 1 meter, with 4 meters, but that's risky, and I prefer that leftover. If you fuck it up, you can get 3 lines out of it. Hopefully, that's, I think, safer than assuming that everyone does it perfect. We need to give the people a little bit of leeway. Okay, now I need to find the LED strip that I used for testing, because I know I had one somewhere here. Not that one. Hopefully it still works. There we go. Found it. A little bit of basic stuff. That's the 3, that's the 4. We can disconnect these ones. That should be fine. Okay, this is all not needed. Nope. Pretty sure I made a broken pin here. There's... Oh, okay. That's all the disconnect wires. Also not needed. Cool. There we go. Okay, at least we got this one up and running now. Now we need ground. That one connected. That should be fine. I can disconnect this one, and then the chip should work, because then we do data in there. Can put the pin in here. We have our starter, so we can technically do that. So if I disconnect that one, yeah, cool. Okay, that is good. Now I need to find that one. let's add some solder so it becomes a lot easier. Yeah. That's one. That is two cleaned up. Cool, I can turn that one off. Where did I put my cables that I can plug in? There we go. This is not the right cables. Where are they? I need the reconnectors. I know I have a pack of them here. There we go. Found them. At least these should work. So we can remove this one, move this to the side, and see where that one goes. Because now we can do this one. That should be extenders. That should be, yes. Okay, so that was ground, this was ground. Ground in to ground here. Which one is ground? But the ground is white. Ground is, okay, white is ground. So that's this one. Okay. Then we go for the data, plug that one in, and that is always center, so that is the easy one. Ooh, don't bend the metal, please. Okay, then we get power. Cool. And then power is the last one. Double check that cable's actually on the power side. Yes. Oh. Wow. I didn't dumb. They didn't check where the cable starts, so this is incorrect. I need this one. Damn it. Oh, I need this one. It's a small test, so boo. Yep. Okay, fucked up. Let's do this one again. Now I don't need this one, so now I need to connect the pins. Which is a whole different breed. So that's half, which I don't have that much. Because everything is 1-to-1, which sucks. Where did I put those? I need to clean this up. I don't have many of those anymore. Shit. I have one, I have two. I'm just ripping off from another project, which I don't use that much. So there we go. Okay, cool. Okay, so these are the old cables. Now we can do this. So actually blue for data. Now we go brown is power and ground is dark. We are trying to match as much as we can. So at least we got that one working. So now we can grab this one because the data goes into one direction, and the other side I thought this was the inside and I didn't check the data, and the data goes that direction. So if I put the data in this direction, it doesn't work. That was a slight dum-dum. Didn't even realize that, but still reversing it should be applying to the same, which will I check later on. Okay, so now we go voltage that direction, so voltage, double check that the outside is voltage, yes. Then we go for ground, and data should be this one. And then this one and this one. Cool. Alright, so this LED strip should work. And it's a bit longer than intended, but that should be fine. We can just run it from the LED strip. The power of the LED strip and the amperage should be fine on this distance, and as long as I can do this connection. This is where I fucked up. I hope there is a small charity festival in behind my house. They are walking for cancer research and collecting money to battle cancer, and they're playing a lot of sound. So I think my headset and my microphone should be good enough to capture that, or that you guys don't hear it. But if you hear it, sorry for that. But it's for a good cause, so that's the most important part. Okay, so we have this one now connected, so I can put this one off, remove the fan, and don't hit my fingers, please. Thank you. There we go. Alright, now, oh crap. Yeah, right. I don't have a USB slot and I need to upload something. That's my camera, that's my other camera, and that's my Bluetooth connection. So this one is... oh yeah, that's my old headset, so I don't use that one. So hey, I have a free slot again. Woohoo! Nice! Right, slot this one in. So I have no clue what I put in here. But at least it's already working. So LED strip is already working, which is good. I kind of want to check the code. Which did I put in? Because I think this is just a basic RGB. I also have no clue how far this will go, so I think this should be fine. Yeah. Cool, at least it's working, so we can disconnect it again. Because doing that, and the cable's a little bit heavy, so let's put it on here. A bit more on the table so it doesn't fall off. There we go. Okay, so that is good. Now, ground is dead, so we're gonna grab this one. Let's make it as correct as we can. We have grounds like that. We put this one in, so we open them up here. There we go. Then we put it in. Okay, this is not going right again. This is the second time I'm doing this, so. That should be correct. Okay, clipped on, that is good. Now we should be able to grab a second one and then say ground up. And that's the end one, so that's the last one. We can grab one of these. Now we have always going up, so this is the direction we need, so that is ground is white. Yes. So now we plug this one in. Hopefully this one goes smoothly. And again, that it's this one, huh? Okay. So that goes easy, but the moment you put it in the lamp, ooh, then it becomes a problem. So I need to have some distance inside the lamp where the LED strip can go in and out, so you can actually connect it on the outside. Or can we install it like this and can we, no, we cannot move that. This is too big to fit in the lamp, so we cannot do a switch in out like I did with the previous version. Oh, that sucks. Okay, but I want to test this one now, so will this work? Awesome. So that works. Oh crap. That's pretty cool. Like it saves me 10 minutes of soldering. 2-3 minutes if you get it down of just connecting, be a little bit careful and go with it. Awesome. Oh, that is cool. That's neat. But we also have resistance to concern about. Like if we do this in every layer, then chaining it up, this cable connection is gonna be the resistor. So that's gonna take the most because it's not a direct solder, it's an indirect holding point. So instead of that it solders and joins in, it's like a small connection just pushing in. And that's a problem. So we get that and do that. So okay. So we get that. At least we're getting there, so now we can grab the next one. Grab this one. Oh. So we're going into the next one. I mean, it's always ground somehow, huh? 3 in a row. Now it's 3 feels ground. Okay, I'll line them up. Close it down. And on to the next one. Put this one in. So this one can now also be tested. There we go. Oh, this is exciting. This is cool that it works like. So we're gonna grab the next one and see where it goes. Yeah, this is pretty cool. Pretty cool. Pretty cool. Come on. There we go. So now we grab that one here, click it in again, go to the 5 volts going up, put it down, keep the pins and check it. It's probably always ground. Yeah, it's always ground. Like, what the hell? Okay, yeah, this is pretty fiddly. This one is not giving me any luck. Almost. There we go. How can we improve that to make it stable for everyone? Because this is my 6th time doing this, and this one gave me the most trouble. Like, can we design it in a way that, or can we make a small tool assist that actually improves the setup? Maybe. I need to think about that one. So that's next one. So that goes continue on the power wise. Let's see if it fits. Well, I need to take really small pictures of this and see where it goes and that everything goes in. Oof, yeah. Can I make a tool assist for this? Because if I put it on and then just do that, I think I can, but then you don't see it, of course. Ooh, that's a problem. So 5 volts going up again. Okay, let's check the chip. There we go. That is cool. That is just cool. That. I know they exist, but you just don't realize it until you realize it. Which is cool. That's the other side. I put this one in so I can do here. 5 volts go in that direction, so we have the clip here. Oh, that might work. That's cool. Going up. Okay, this one is a little bit cut crooked. Oh, my Discord is still on. Sorry. There we go. Someone on Discord. Forgot to mute the Discord. Right, power up, power in. Alright, so this one's a little bit crooked, so hopefully this goes alright. Right. Let me go to the next one. Oh, check. Each line we need to check. Because I have no clue when it stops. Right. That one seems to work too. Awesome. Yeah, now we need to design it in a way that I can install this into the lamp. Or this one is too... Yeah, that's not gonna work then. Oh, then you need to print in 2 layers. Oh, if I print it in 2 layers, I can just click it all in. And click it all in. And then put the cone in the... Oh, do I want to do that? Oh, that's gonna take more time, of course, and more plastics. Well, I'm gonna remove a couple bits. So if we do it in 2 parts, then you don't have to physically install this while having the lamp in your hands. Oh, I need to think about that one, because if we make that proportional safe, is that a better option? Do I need to spend more time or that? Or I think I need to do that, because that's just more responsible for average people. Because I know what I can do it and I have the patience for it, but if you want to sell an actual good product, then you need to assume that most people don't have fucking patience for it. Ooh. Alright. Because I already think that this is for most people the limit. And again, ground is going up. There we go. That continues. Okay. Oh, see? Wrong direction. You need to watch out for that. Oop. Ground continue, 5 volts. There we go. Make sure that everything is connected. There we go again. Awesome, that works too. As expected, but you always want to check it a little bit. Then assume like everything works. You install everything. Why it's not working? That's not good. But yeah, so this goes slow and steady. Again, I hope that everyone is having a good day. For me, I'm still a little bit off. I've done 2 weekends of just events and must say, it hit me like a truck. So I'm still not fully back to my own sleep pattern that I can enjoy. And I still feel a little bit drowsy the whole day of like, why am I doing this again? What am I doing again? And how am I doing this again? And like, well, you get there in time. There we go. So now we have that one. There we go. But that takes time. It takes a little bit of time. But hopefully in 1.5 hours a friend comes by and then I'm gonna pack in the lamp. That's why it's not standing in here. And hopefully we're gonna bring it to the forest. Make a video about it and show how the big lamp disconnects and everything. And I hope that video is excited for everyone here. A little bit scared about it because, like, oh, if it doesn't work, then I spent a shit ton of time on it. But it's hopefully gonna be cool. Like, I was like, I can put it in my house and everywhere. I was like, but that doesn't feel cool or interesting. So I was like, why not put it in the forest? Put this electrical lamp in the forest because I can. And make a cool demo about it. And then I was like, yeah, that's really cool. Then I need someone else because I cannot do that alone. All right, voltage on that side, voltage on that side. Yep, that's gonna be cool. Voltage, voltage. Boop, boop. Alright, so we had a couple. We're almost there. We're almost there. We're almost there. So we got this one. It feels weird that the cable is this thick, but now we actually can do that curve around when it's needed. So 5 volts on the right, opening up, should be this side, open that one up, and see where it goes. There we go. So I'm right-handed, so for me, right side plugging in is a lot easier. Voltage on red. I plug them in. Like most of the times it goes correctly. It's pretty easy. So I think you can even use a zoom thing to actually see how this fits correctly. So you don't fuck it up. And always double check that the pin is in. And going in. So I'm gonna do a check again. There we go. That looks cool. But yeah, so when my friend arrives, then we're prepping to go to the forest, and I'm gonna shut down the stream a little bit sooner because I need to eat before that. And then this is my first video that I have written down the script, what to say, what the angles are. So hopefully this one is a little bit better than my impromptu shorts. Double check. And hopefully it becomes awesome. But yeah, the rain, there is no planned rain in the Netherlands currently, so that should be fine. But if the rain comes in, I'm screwed because this lamp, not watertight at all, not waterproof at all. So the water will slide down it, but the plastic has no sealant to it, so if it is wet, you can guarantee the LEDs will get hit by it. So yikes, I don't want to experience that one just by accident, but hopefully making a cool video. That's the excited part of realizing it. Alright, so this is going better. And this one. And then that's one going up. There we go. I'm happy I picked for black because the plastic itself is just white, and white on black is easier to spot than anything else. Normally I pick up the white strips, and I went for black just so I was like, I want to do a different one because this is a different LED strip than the other one, but it looks the same. But there's a different type. This is the old ones I have are SKs. These are WS. And if you look at them, they're almost bloody hell look the same. So you don't want to mix these up. So that's why I made them black. But now I found out like, hey, actually the connection is, you can actually see white to black when you do the transfer part. That makes it a lot easier. Oh, that saves a lot of time. Because then, like, is it on? Is it on? Is it on? So let's grab a couple loose ones. So 1, 2, 3, 4, 5. 1, 2, 3. 3, 4, 5, 6, I think. 6 should be good. So there we go. Got a couple loose ones everywhere too for testing. Then we get to this one. Oh, there we go. And now we need this side. Data connection. Power on the top. Power goes to red. We just plug it in. Come on. And there goes ground again. We had a good streak of good flat ones. But now I'm having a little bit of bad luck again. Come on. There we go. And then put it in. There we go. On to the next one. So there we go. Voltage on the bottom, voltage on the bottom. Click it in. There we go. Voltage going up, voltage going up. Clicks in decent enough, yes. You always wait for the click so you actually know that it sits in, otherwise it gets loose and then you get the disconnect. Not the best thing to have. And that's this side. Guess power goes into here. And then voltage up. Arrow up, good direction. Let's open it up a little bit more. Five volts ground, voltage on the red. Close it up, and there we go. Next one. And after this one we do a test. We kind of forgot a couple layers to test, but I feel fine now, but you never know for sure. So we're gonna test. After this one. Five volts ground up. Cool. Alright, let's see if it blows up after not doing it. See? We're fine. That's awesome. Cool. Awesome. Cool, we got this one. So on to the next steppy. So that's right side, that one. There we go. There we go. Data going up. That should always be correct, but I prefer to double check it or triple check it than not check it. I've done that enough already and like, oopsie, my mistake. Nope. Ground is going over again. So let's make it pinch. And there we go. Ground seems on. Yes, 5 volt going up. Then we can close it. On to the next one. Then data going up. Ground on top. Voltage down. Alright. There we go. Ooh, almost bent the strip. Yes. Because you can make an accident bend here if you don't hold it proper enough and there's enough space here, this will just bend. So you need to have some grip here, hold your fingers, then shove it in so it doesn't have space to actually bend. Then we get that one and that one, yes. So voltage, data line going up, voltage on the right, cable red on the right or on the top right now. And we're gonna see. So I think for now we had 2 really bad cables and no, 3 bad cables that needed a small bend. But all the others are going in smooth. Itchy ear. Yeah, itchy ears, never fun. So that one goes up, 5 volts in, DC ground. Yes, cool. So technically I've not done this correctly because I fucked up again by not seeing which the direction cable going through, but that should be fine. 5 volts going up. So I'm gonna order new LED strips soon, so I have 3 more test versions to do this. So it should be fine, should be fine. We're not in a pinch yet. But yeah, 60 days. I'm still grasping how to make PCBs. That's the hardest part for me because like I hear a lot of people saying like, oh, that's pretty easy, just do it. And I'm just mentally getting stuck there. I'm still understanding how does the program work. Where do you find all the data? Is the data there? Does things sync? Or why is this not working? Why is that not working? So I need to process that before I can make my own one. And I'm not sure what I can make and or how I can make it. So hopefully the price is going correctly and nothing goes wrong. Hopefully nothing goes wrong. That's the scary part. Okay, 5 volt stop, data up. Yep, always do the safety checks. Because I've fucked it up enough that I know my lesson right now. It's this one and this one. So we have 2 specials, one, right? So 1, 2, 3, 4, 5, 6, 7. This is a normal one. And then we have the extendable one. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have the starting, the end one, that is this one. Yeah. Oh, yep. Okay, almost made a mistake. Voltage on the bottom, data going to the right. See, this is why we check. Are we all in? Yes. Ground to that. because we cannot use this one here because that one. That's fine, that's fine. So now we can go for the long one, and then we are correct. Voltage down, cable red. We switch it, it should be voltage up, data to the left, ground on the down. There we go. Cool. Yeah, there we go. And now we can technically get the long one in, and that's the end. Oh, there we go. 5 volts on the bottom, 5 volts on the top. So if we do it like that, it should be fine. Okay, that one's having troubles. That's a little bit short. I've not cut that one correctly. But still should be fine. So go. So if we connect it right now, then maybe we get a stopgap of this one. Okay. I have no clue how many LEDs I put in this, but they're all working, which is awesome. They're all working and they're all moving and they're all going to the end, which is awesome because then this cable actually works. So that removes every end times 16 times 6. So that's 160 is for 10. We go to half, which is 5 times is 80. So we saved 69 soldering points. Yes, the data, everything goes a little bit more down, but the chip is gonna run this 112 LEDs in total. So that should be. And resistance wise it should be fine. Power wise this is also, we're not extending to the next layer power or data wise. The chip is gonna only power this part, because then we can stack more. Because if we do one chip at the bottom and we have 5 layers, then the resistance of these cables will kick in data length wise, and it will drop and get faulty, which we don't want to do. So that's why putting one chip in every layer is safer, because data, distance, and power and ground, everything becomes 112 LEDs in total. Just 112 LEDs in total. Which means that I'm not overextending to 400, 800, 900 LEDs. I keep every section to 112 LEDs, and that's it. Which makes things a lot safer. At least that's what I assume, and that's how I think power works. So if I'm wrong, well, something will burn and it proves me wrong, and I need to learn what the fuck did I do this time. We're getting there. Oh, we're getting there. Which is really cool, because then we have this system. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm missing one. I'm missing this one. This is number 16. Okay, 16. And by moving it and it's not disconnecting, it's all still working. So moving it like that should be fine. Cool. Okay, we need one more, because I want to have 16 connections, at least to see how it works. Where's my end LED strip? There. Yes, for the good perfect, it's not working correctly yet. But more LED strips are coming, and then I can fine-tune that, and hopefully in the week of ordering I can redesign the lamp itself so I can test that part correctly. Oop, come on, go in. There we go, that's better. 5-volt top, data goes in, clip on, grab the next one. That one should be on the top there too, because then everything looks the same and behaves the same. But yeah, these things are a lot easier and you don't need to solder for this. Oh, nope, there goes ground again. There we go. Okay, so this last one should work too. So that's 16 in total, and that should work, like as long as you don't rough this up, and this part of the plastic will sit into my design plastic, so this should be strong enough that this don't get forces like that or gets pulled too much. Like I think by the installing a little bit of tightness that you click it in, and that should be fine. Yeah, that should be fine. Cool. At least I know it's working, and that's exciting. Woohoo! Okay, that's one step. That is one step that I know this is gonna work. Okay, now still the PCB in the design part, and then we're one big step closer to actually put it on printables and hopefully sell it to you guys. And like, I'm still nervous. But I will get there. Oh yeah, time is going fast. So I wanted to go for modeling too, but I need to eat too before my friend comes over so we can make a really cool video in the forest. If the weather permits, and as far as I know the weather is permitting it, so gonna make a cool video about the big lamp, and I also can make a short explanation video why it's taking so long, because I get too many people asking, when is the lamp ready? Can I have the files? Can I prototype for you? Can I beta test for you? Like, that's okay. I have 5 people already beta testing the hell out of it when it's ready. So I have that, and some people like, yeah, can you give it to me for free so I can beta test? Like, that's not how beta testing works. I have 5 people that just they just want to pay for it because they appreciate my work. So I got the testers, and it's okay, but I don't want to finish up a half. I don't want to give you guys a half finished product that is shabby made together. I want to do some prototyping first, so I'm doing that internally. Then those 5 are gonna test for me, and if that works, it's gonna go live, and hopefully I can do that in a couple weeks. If everything is going as planned, then a couple weeks. But I don't have control about my whole life directions and what happens in my life, so things get delayed, and I cannot say as one person like, yeah, it's gonna be done tomorrow, without knowing that I can make a PCB in a day, get it ordered in a day, get the electronics in a day, get it printed in a day. I cannot stop that, so have a little bit of patience. I'm working on it. I'm doing my best. I really dislike making false promises, so gonna say this. I'm gonna do my utmost best to get this lamp on printables for you guys. But yeah, see you next stream. Later!